All right, so at this point, thank you guys. We're gonna segue into our first discussion. And if you go back to the main page for this LSSW, you'll note that we have a series of guiding questions that we really want to talk about today. The first one, I'm going to place this as a link in the chat. And again, we're going to be using a Jamboard. So this is Google Jamboard. To open up the chat, if you're in the app, then it's the lower right. I assume it's probably similar in the web browser. And as you join this, what we've got is we've got our question as a prompt. So our first question is going to be, who are these key stakeholders and users of map products for Artemis exploration? Okay, so we're thinking about who's going to be using the maps of all different scales. And specifically, we want to break this into pre-mission users, sin-mission users, and post-mission users. And then also we have some pink stickies for all mission phase. Oh, hey, thank you, Ricky. We weren't sure we would be able to share this, but that is really fantastic. Okay, so you can, hopefully you've got this Jamboard open. And there we go. Somebody's on the board already. Please feel free. So on the left side of the screen, you'll see the option to add a sticky. And we want you to add stickies. This is a community participation event. We want you to tell us who is using maps at different phases. So maybe I'll pause here for a minute and I'll go in and add a sticky. And we also have time if you want to raise your hand and speak about this. I'll call on you so that we can talk about who our primary users are. Oh, this is great, guys. This is exactly what we were hoping for. So maybe if we could get someone to unmute or raise their hand to tell us a little bit about traverse planning teams and how traverse planning teams end up using maps. Someone's added that sticky, and it could be them or anyone else.
Well, I added that sticky, so I guess I can just say that, like, when we were doing this exercise for A3GT, the maps that we were generating was critical for defining where we would want to stop and go. And, sort of the work, it was an iterative process of trying to constrain where the astronauts might get in the amount of time they had, and places that were interesting. And so maps were critical for that.
Yeah, I think one of the challenges there also is, or did you ever feel that you were relying on the map? Because I get nervous sometimes when I rely too much on my map. Like, oh, because then it comes down to the mapping. What do you think?
Yeah, well, I only had, like I said, I pretty much had one contact. So yeah, I mean, it was a map. It was a combination of mapping and also analysis of other characteristics of the geomorphology and sort of the materials that were present there. So yeah, I mean, it's relying on it doesn't make me nervous because it's the best data we have, right? I mean, we know we can do it.
I guess it's been my own uncertainty about my mapping. Like, oh, do I really like this contact here? Okay, so this is getting populated. I'm gonna call out some other folks to talk. You don't have to have presented today. This is an open discussion. And again, I've got my participants open, so raise your hand if you'd like to verbalize some of what you're seeing happening on the screen. Can anybody talk about maybe how mission control ends up using maps? This is something I very much would love to hear about during a mission. We've got that as a green sticky on there. Can anybody tell us about how mission control uses maps?
Yeah, this is Jim. I can speak to that a little bit, and I'd be interested to see what other people might have to say. But the flight controller is going to want to use this for several different reasons. One is to track location relative to the stations, and so the tasking and flight controllers are maybe less interested in the moment with the science that's being returned, but it's a good way for them to track the science that's coming back. And it's also a localization means for understanding relative to what needs to happen at a station where folks are. So when we talk about mission control is going to mean lots of different things, because the science back room is actually kind of part of this mission control. So we have the flight control room and then the people that are all around it. So when we talk about mission control, we should probably start to be a little more granular and like what people specifically might be using these products for.
Thanks, Jim.
This is Lauren. I'll just jump on what Jim added there. So the flight control team will also care about crew walkback time. And so different terrain types and geologic units might affect their traversability through those areas. So kind of at each station, you're also tracking what it would mean if we had to immediately head back to the lander. So the geologic maps and the mission control and flight control team's understanding of those maps is definitely important.
Yeah, and that's where I think the clarity of the map is so critical too. Okay, great. Please continue to add stickies. You can post, so we can access this and we can go back. You can actually post on top of someone else's sticky. I know that feels weird to do, but that way we can collect as much data as possible about different users. What about, I saw one here that was added early on, historians, media, and other forms of public outreach. I'd love to hear from someone who can tell us a little bit about how maps get used more broadly beyond the science, maybe the teams that are actually doing the mission. So would anybody like to speak about that?
This is Fred. I could give some examples.
Yes, great. Go ahead.
Sure. So specifically for Perseverance, Curiosity, we push out live updates of the rover position. We push out dates for the heli position. We push out updates of samples. All of that's, some of it's almost real time that we push out those things. So, and the public does follow along. In fact, I have a few key public people who bug me when something's wrong or some value. Why is that value changed? So absolutely, it's something. It's integrated into the mission. It's something we do on purpose every day.
Yeah, and now that I've asked it, I realize that I follow that on Twitter just specifically so I can show it in my classroom. So, which I saw at K through 12 and undergrad educators. So educators are absolutely on here. What about, for all mission phase users, somebody has added a sticky about civil engineers, construction planners for lunar bases. I know we're focused on Artemis 3, but we do want to keep thinking about the future too. Can anyone speak about how maybe civil engineering and, construction planners might be using geologic map products?
Yeah, this is Rob Mueller, NASA Kennedy. Can you hear me?
Yes, I can. Go ahead.
So I'm involved in the excavation and construction world. And it's early days, of course. We're still trying to define what the needed infrastructure is. But I would say that the first thing we need is topography and regolith properties. For example, if you're building a foundation or a road, what is the bulk density of the regolith? Does it need to be compacted? Does it need to be stabilized? Just the basic civil engineering parameters are required, and those could be mapped, just like the other variables that were shown earlier. So I think topography is the very first basic thing we need, and then the next thing we need is often I see maps and they somebody will plan a traverse, for example, and there's no data that shows the geotechnical context for that traverse. So, for example, if you drive on the rim of a crater, it may be very, very soft, and then you might not make it. So those are the kind of things we're looking for, is more context, not just the maps as they are today, but more metadata on the topography.
Thanks. That's very helpful to know. I really like, there's a comment in the chat about geosophy. I hope I'm saying that right, Wayne. So our astrosophy, right, of how we understand the meaning of a place, or selenosophy, I think that's a good one. Okay, so we're running up on our first block of time. So I'm going to move us on to our second. We have a second Jamboard slide. So you'll notice at the top of your screen there, and you can continue to add stickies to this. You can come back to this. We'll continue to post it so that we're collecting this data. But if we move on to the second sticky, so at the top there, Ricky, there's a to go over one. Our next question then, and this gets at some stuff that we've talked about that's come up, especially in the chat this morning. What approaches do we need to adapt and evolve to ensure that the Artemis products are broadly useful to that wide range of stakeholders that we just listed? So for example, we may have processes that we already have. So those we're going to somehow adapt them. Or we may have maps that are just straight up brand new. We've never used them before. And I'll use as an example for our adapting current approaches, Isaac's talk, right, showing current military, and then this is how it could be adapted. Those are some good adaptive ones. What would be some new maps too that we maybe don't have before that we need to make for the lunar surface? And let me check the chat here. Yeah, a great comment here. The reason that the ISRU and construction planners need to be involved throughout the mission is to get an understanding of what can be requested versus what can be provided by traverse activities. What can be requested, provided, and done so all very safely. Maps of bearing capacity and thermal stability, depths for volatiles currently exist. There's some models, and they'll be tested within upcoming missions like Viper and Prime 1. And then is there a new link to the Jamboard? Fred, nope, it's the same link, but at the top of the screen, you will see it's one slide and two slides. So click over to the second slide. I'll send it a second time, but just in case. All right, so let's start with some adapting approaches here. We've already had a little bit of conversation about some geotechnical properties and how useful that would be for things like construction, aggregates. Incorporating. Oh, great. Can somebody please talk about, there's a comment here, we need to adjust the mindset about making a geologic map on a body where bedrock outcrops are not the norm, right? Now, I live in the Southeast, so I'm always looking for outcrops because it's very green down here, but this is a totally different thing on the moon where we don't have outcrops. So would anybody like to speak to that?
Well, I wrote that, but Jim's already spoken to this some. I mean, it's just that we don't have unit boundaries in the same way we have on Earth mostly. Mostly we have regolith covering the whole surface, and we have mixtures of underlying materials in that regolith at the surface. So we just have to think about how we're sampling and guide our geologic mapping approach appropriately, draw boundaries. So I don't think it's impossible. I have the same problem with vegetation out my window here. Like we don't have a lot of outcrop up there either.
Yeah, and then it becomes a challenge of, are you drawing an outcrop map, right? Or are you drawing a geologic map? And you want a geologic map, but you don't always know the underlying, the bedrock that might be there. If you are trying to get into the chat, right, there should be a button on the bottom of your screen. That's one that says participants and one that says chat. If you click that chat one, then you should be able to get into the chat and access our Google Jamboard. I've got a question here about that.
I saw Jim's face briefly there. Jim, can you add to what I said, or like?
Yeah, you're absolutely right. I mean, I think it's really interesting is that, again, we don't know the results of what we're doing here. We have to do this and figure it out. Last year we keep coming back to JET because it's the closest thing that we have had to kind of emulate these analog missions. But last year we were in a place where there was lots of topography, and topography is kind of one of the key things that we can use to make geologic units in the absence of topography. So last year we had topography, cinder cones, lava flows, and then really flat superficial deposits. It was interesting because we made the margins of a boundary, margins of a lava flow, and when the crew got out there, they would walk up and say, "Where is the contact?" And so, there was a fundamental misunderstanding about what we were displaying and had us to go back and be like, okay, well, you're not going to see, I put a comment in the chat. It's like, we're not going to see contacts like we see in a Geology 101 book. It's just not going to be that way. In fact, it's going to be the exact opposite of that. This year, we are working in an area that is far flatter and has a bunch of alluvium, and there are textural differences. And this is where the comment about radar is becoming really helpful, because just even like first order radar data is helping understand like just distributions of material when we have a lack of contact. And so we really need to get in that frame of mind, is that we're not going to see contacts like we expect contacts. We're going to see distributions of boulders of different sizes. We can kind of predict where they might be, even if we don't see them in the data that we have, because, you know, we're looking at 0.5 meter ortho images, maybe 1.5 meter or 2 meter DEM. So yeah, we really need to have that switch into like, what are we going to be seeing and how can we capture that information? Because it's not going to be this classic geologic unit like we do on Earth, or like we try to do on Mars and other bodies. So, and then there's also a scale issue in there as well.
Great conversation. And you can see that this Jamboard is already, it's getting jammed with lots of good stickies and lots of conversation. We have a comment in the chat from Mark Hunter about in the 60s, Lockheed Martin was contracted to investigate requirements to establish a lunar base for some extended operations. Most of the factors are applicable today. And Mark, you mentioned that a copy of those reports can be released soon. Can you speak a little bit about that and tell us where we'll be able to find those reports? Is that going to be with the USGS?
Yes. In fact, it was something that was brought to our attention that a researcher, I believe in Germany, was trying to find copies of this, knew that it existed, but couldn't, through NASA and through the Library of Congress, couldn't find a copy of any of these reports anywhere. Turns out, you know, the only known ones are in our archives here in Flagstaff. So we've gone through the process of scanning them, and we have to go through some additional steps of review and compliance before they're publicly released. But we will be getting those out there in digitized, in just PDF format here in the next couple of months.
Great, thanks, Mark. Another comment in the chat, there's some discussion about geologic versus geomorphic maps. And I know Hannes and I have had this conversation back and forth. Hannes, do you mind sharing a little bit about what you view as the difference between geomorphologic versus geologic? And I see there's also a comment by Dave Kring in there, but Hannes, are you there? Okay, you got background noise. Yeah, no problem. Yeah, so geomorphologic is it's very difficult on the moon, where we can't go out and walk around just yet, right? To know are we making geologic maps and or geomorphologic maps? And there's again some conversation in the chat if you want to read through some discussion about that terminology. All right, with our remaining time for this discussion, I want to get down into these green stickies. So we've got a lot of blue for adapting mapping approaches. I see someone's added some mapping standards. I'm a big fan of standards, so yeah. But down in the green, I saw this really interesting one of fully 3D tomographic mapping from the global context to sub-meter resolution. For example, including things like interior spaces like concavities, lunar lava tubes. Can anybody tell us a little bit more about the vision for what that map product would look like?
I wrote that. The idea would be to have like a planetary globe. The current technology of planetary globes mainly encompasses only like a surface, like a hollow surface for the planet. But something like that will be able to map, I don't know, even smaller bodies like asteroids that are being mined, or it could be used for to visualize subsurface structures as big compared to the size of the body as the lunar lava tubes, which are quite big. They're estimated to have to be thousands of kilometers across and kilometers wide.
Yeah, that's really neat. It's exciting to see where the future of mapping is going. There's also some conversation in the chat about stacking maps, map stacks. So I think it was Dave Solar and Alex. Would either one of you want to speak up and tell us what you mean by a map stack?
Yeah. So, for example, in Illinois, they've been doing a lot of this mapping where there's a set of codes associated with a polygon, and it indicates a succession of geologic units downward in a stack to maybe 20 feet or down to bedrock. It's very useful for packing a lot of three-dimensional information into a two-dimensional map. Of course, you need to be able to parse out what the code is. But you know, I've heard discussions about geologic versus geomorphic maps, and you know, most geologic maps, or not most, but many are a synthesis of process and materials and geomorphology. And so I tend to have a pretty broad definition of what a geologic map is. While I have the floor, I wanted to also note the importance of standards, and engineering properties were mentioned. I'm very curious if you're standardizing in some sort of data schema the engineering properties and other geologic characteristics that you're gathering. We're trying to do that in the GEM standard by adding new tables. So if anyone's interested, I'd like to hear more about it. Thanks.
Yeah, thanks. That's a great question. If anybody has an answer for that, please add it to our chat. We're coming up. I want to make sure that we do have time for a longish break. We're going to reconvene at the top of the hour with our next set of talks. But before we get there, I just want to open up the floor. If there's something else that somebody just absolutely has to share, we've got this great set of data here. And if you're just twitching around in your seat and you just want to share, please feel free to unmic and do that.
Yeah, this is Mark McLaren with USGS. Just quick comment on mapping standards. So I sit in on the Artemis geospatial data team, and that is a topic of conversation at this point, is what does a mapping standard look like and how will it be implemented in the future? Things are still at a very early stage, but it's a topic of conversation going forward. So it's being thought about, you know, things along the lines of how to navigate with the grid system, which reference frame to use, as well as naming conventions for different studies at the sites. So I just wanted to mention that out there, that because standards were mentioned very, very well, the one thing this talk did is, you know, address the need for a mapping standard moving forward. And that's something that's being, I guess, looked into at this point.
Great, thanks. It's nice to know that standardization is coming.
And to Jim's comment real quick, these are geodetic standards. The mapping standards might be done separately.
Oh. Okay. All right, thanks, Mark. I appreciate it. Any other final comments here before we break for our little to warm up our lunches? Okay, then we'll go ahead and we'll break here. The Jamboard stays open, so feel free to keep adding to that. Otherwise, we're going to reconvene at the top of the hour, and this is exactly how the rest of the meeting will go. We've got more Jamboards for you in our discussion later today, and then we've also got some more for you tomorrow. So see you in about 19 minutes. Thanks.
Thanks, Jeanette.